So I'm going to talk about Hadoop-BAM and SeqPig. So I'm a professor of computer science at Aalto University. That's located in Helsinki, Finland. And here's a list of people that have collaborated on the two papers I'm talking about. But instead of kind of focusing just on the papers, I thought I'd give a bit of motivation what we're doing. So next generation sequencing and big data. So this is what you've heard over last day and a half. We have NGS data growing every 5 months, doubling. And this is much higher than Moore's law rate for CPU growth, Farade's law rate for hard disk growth, and also Farade's law for network capacity growth. So this exponential growth is outgrowing all of these. Another thing that you might be aware of or you might not be aware of is that the processor clock speeds have stopped increasing. So for example, around year 2005, there was a paper by Herb Sutter saying free lunch is over, where he said that the lazy programmer days are over. If you want to get better performance, you have to each year make your code more parallel. That's the only way to get better performance. So the growth on CPUs is just very minor, and the only way to go forward is to go for parallel software. And we really have to go for programming models that are efficient and need to be able to exploit the parallelism, and also the data volume growths that are higher than even the Moore's law growth using parallelism. We have to go more and more parallel all the time. So the number of cores is growing, and things like GPU programming are making inroads. Here's another slide I showed to my students in my class. So the title is from a guy called Jim Gray. He's a Microsoft. He was a Microsoft guy doing much of the work on their side. Let's see if this works. What is this? Well, this is plotting the price of storage actually in here. This is the price of hard drives plotted on a time axis. This is the price of main memory plotted on time axis. This is the price of SSDs plotted on time axis. And if you take a look at these plots, one of the things you can see that the price of main memory is trailing the price of hard drives by a decade. So if you were able to buy a certain amount of storage 10 years ago on hard drives, you should be able to buy the same amount of storage today in main memory. And of course, main memory and SSDs are radically faster than hard drives. So workloads that were viable with hard drives a decade ago are now viable in RAM. So one should only use hard drives for data sets that are not yet economically viable in RAM and SSDs. So things like in-memory file systems are going to be pretty big. So there's things like Tachyon that's using the combined memory of all the workstations in your cluster to provide a file system that is able to get you way faster IOPS than any hard disk-based storage system or even SSD-based storage system. And going for these kinds of things, for things that you can actually fit into the combined memory of all your workstations, makes a lot of sense. So the big data applications, hard disk-based massive storage should consist of applications that were not economically feasible a decade ago using hard drives. Okay, so Hadoop. So what I see Hadoop as? Well, I see Hadoop as more of a Linux distribution for big data. So if you go to listen to Doug Cutting, who's the guy behind Hadoop and ask him, okay, what are you guys doing? He's saying, well, we're building a distributed operating system. So he's not talking about doing a particular programming model, MapReduce and whatnot. They're saying, okay, we're building a distributed operating system. What do we have? We have a distributed file system. We have a distributed scheduler, and we must have all the other things in place. So Hadoop is, in my opinion, going to be the open source distributed operating system distribution for big data. So it's more, so companies like Cloudera and Hortonworks and Co, they're operating in the same mode as Red Hat and Co. They're gonna have a bunch of open source packages that are put together, are tested together, and then you go and pick the ones you use for your own application. So the original design is based on Google architecture design. It's using cheap commodity hardware for storage, and that was the killer feature for it initially. It has distributed fault-tolerant file systems. HDFS is the main memory-based. Tachyon HDFS is the hard disk-based. Tachyon is the main memory-based system. It has batch processing that we've been mostly talking about. Hive and Pig are hard disk-based. Apache Spark is something that is making a huge splash. And this is once more main memory computing, so moving from hard disk-based storage and computing to main memory-based storage and computing. It has parallel SQL implementations for analytics. So actually having a SQL engine that's scalable to petabytes of data in your data warehouse is something that you can have for free if you move your data to these platforms. It has fault-tolerant distributed databases, distributed machine learning, text indexing, search, etc. And MapReduce is just one programming framework in this kind of operating system. So commercial Hadoop support. Cloudera is maybe the biggest player. Just to get some idea, Intel bought 18% of Cloudera a while ago. A couple of months ago. They paid $740 million for that, so that values them at around $4 billion. And this is now, I saw some Cloudera guys and they were saying, now we have some money to buy some development, put some coders to do interesting stuff on top of this framework. So they are investing very heavily into this platform. Hortonworks and Mapper are there. So what have we been doing? So in late 2010 we released a library called Hadoop-BAM, which is a library to interface NGS data formats with both Hadoop. And actually the same library is also being used to interface things with Spark. We support file formats BAM, SAM, FAST, FASTA, QSEC, DCF, VCF. Some file formats like BAM are notoriously bad for parallel processing. So they're just horrible. We did the footwork needed to get them interfaced. We have a version 7.0. We have 2,700 downloads so far, which is quite surprising for a kind of limited interest bioinformatics library that's linked to Hadoop. And the guy who did most of the work in here is actually Matti Niemenmaa. And then Eija and Alexi in here were the guys who were involved. And also Luca helped later on with some patches. Then another framework we've been working with is SeqPig. It's a parallel scripting language for NGS. So it's auto-parallelizing various things. It compiles into Java. And we can basically do SQL database-like things that auto-parallelize using this framework. This was joint work with Luca, A. Alexi and co. Now a postdoc of mine, Andreas Schumacher, did most of the coding there. You can go look at the paper. So what can you do with this? You can do things like file format conversions, you can do filtering, you can do sorting. Also Hadoop-BAM does sorting very nicely. You can compute base frequencies, do pile-ups, etc., etc. So all kinds of simple filterings, quality control steps you can do with this. And it scales up to, let's say, around running around 50 computers in parallel. So that's each having 12 cores, so hundreds of cores running in parallel. So what's the benefits? Well, it's auto-parallelizing framework for data processing scripts. It's an easy to learn scripting language. Many scripts are tens of lines of code versus hundreds to thousands of lines of Java. So almost nobody writes native MapReduce programs in Java these days. People are moving to higher level languages. It implements a SQL-like functionality. Drawbacks: MapReduce has a 10+ second startup delay for interactive use. And it's a specialized language instead of standard like SQL. So Matti, who did the original Hadoop-BAM, also did a master's thesis. And in this master's thesis, he actually interfaced Hadoop-BAM with Hive. That's a data warehousing solution. So you can actually upload your data into a parallel analytic SQL implementation. So if you do that, so instead of using standardized bioinformatics file formats, you download stuff to a data warehousing solution. Then you get very efficient parallel queries that are auto-parallelized all over your data warehouse. It allows for efficient compression and indexing. And it allows you to ride on top of the software investments that the Hadoop Spark framework are providing. And I think this is the most important part. And things that are actually compatible with Hive framework that we've been using are Impala and Presto and Spark SQL. For example, Impala and Presto are both written from scratch parallel SQL execution engines that are able to do massively parallel SQL query evaluation. And Spark SQL is a similar framework built on top of Scala. So I don't know of any place having this in production, but we have the software. If anybody wants to try, we can give you the software. Future plans: we're porting all our tools over to Spark from Hadoop. So Spark is really the framework that's going to survive. We have a collaboration with some people from Cancer Research UK, where we try to parallelize variant calling using black box variant callers, but that is still very early work. We would like to release a tool like SeqPig, but using SQL. We want to allow interactive ad hoc queries. So parallel queries based on data that's stored on the main memories of all the workstations you have in your data warehouse to get sub 1 second query times for some things. And in order to do that, you need to have in-memory file systems. And also we're looking at object storage integration. And we're helping people. So if you're interested, please come talk to me in the coffee break. And we can tell you more. So that's it. Questions? Okay, 15 minutes.
Why? So do you have any questions?
Why are you moving from Hadoop to Spark? Any particular reason?
Spark is main memory computing.
Yeah, fine.
And many of the file sets can actually fit into the memory.
And now the Hadoop tools can also process that.
Sorry?
The new version of Hadoop.
So for example, this Hadoop-BAM library. There is a tool for Spark NGS processing from the University of Berkeley called ADAM, and it's actually using Hadoop-BAM internally to read these file formats. So let's say Spark and Hadoop are very tightly integrated, so you can use many of the libraries that have been built for Hadoop in combination with Spark, and that's what people are doing. So I would say they're more like parts of the same framework, but Spark being a bit faster and allowing in-memory processing that Hadoop doesn't really do. Well, and things like in-memory file systems are also important. If you have a pipeline, you'll have a huge number of temporary files, like our colleagues in Cancer Research UK were saying, okay, we're generating 10 times the I/O we need because we store lots of temporary files all over the place. So having those in memory is gonna help the I/O bottlenecks quite a bit.
Spark does some kind of semi-streaming also, right?
Yeah.
Spark has Spark streaming, but we don't do streaming with these.
In new Hadoop, the streaming is also there, so, but the in-memory is good.
In memory, yes. Streaming, we're not looking at that.
So, thank you very much.